what's the point of doing covariance and correlation? Because they give you the probabilistic relationship between two things. The idea is if covariance is positive, that means if x is larger than ex, then likely y is larger than ey. Similarly, if covariance or correlation is a negative value, then if x is greater than ey, then likely y is less than ey. This word likely, that means what? That means there's no guarantee. If x is larger than ex, then y must be larger than ey. It's possible y do not larger than ey. We call that covariance. The value is between negative infinity and positive infinity, but correlation is always between -1 and +1. So this gives us a sense how much they agree with each other. So these are the plots about correlation with different values. So the smallest value you can get is -1. So when correlation is -1, it looks like y is negative x. So it's saying that the function y and the relationship of x is like this simple function y equal negative x. If the correlation is not -1, it means if x increase, y have a tendency to go down. But it's okay that y do not go down. So for example, I have a point here, increase, right? But it's okay y do not go down. Instead, y goes up. So this is the region that x and y have correlation 0.8. And if the correlation number is even smaller, the correlation between x and y is 0. It means if x increase, it's possible y go down, go up, or do not move. This is saying that x increase tells you nothing about what happened to y. And then in the opposite sense, if the correlation between x and y is positive, so what is the extreme case? The extreme case is if x increase, y also increase. So in this case, this curve looks like y is basically just positive x, or y is just x. Okay, this basically is a straight line, y is x. Okay, but if the correlation coefficient is like not 1 but 0.8, that means if x increase, y have a tendency to increase, but it's okay y do not increase. So for example, this point go to here, x is increased, but y instead going up, it go down. Yeah, so these are all the points you can have for xy within a correlation 0.8. Here's a funny thing. This one, and this one, they all have the same correlation 1. Recall, what's the correlation? Correlation is basically saying that if the correlation between them is positive, then if x is larger than ex, then likely y is larger than ey. So that means if x increase, y increase. It didn't tell you how much it increased. This graph have a very small slope. This one have a larger slope. Both of them are saying the same thing. If x increase, y increase. Similarly, for this three curve, they have a negative correlation. That means if x increase, y should go down. So this is the same. If x increase, y go down. This is x increase, y go down. But they didn't tell you how much y should go down. So both of them give you the same correlation. And what about correlation 0? This is correlation 0. But it can be also like this, like this, like this, or like this. And very important, correlation and causation are different things. For example, fire and fireman have a positive correlations. Because the reason is, whenever you see fire, the firefighter will go to the place, stop the fire. But does it mean fireman is causing the fire? No. It just means correlation between them is positive. By definition, covariance between x and x is basically variance of x. If we scale one of the random variable by a constant a, you can move this constant out. Variance is insensitive to addition of a constant. So covariance is the same because covariance basically means variance of two random variables. So if you add a constant here, it has nothing on the covariance. And lastly, if you add another new random variable here, covariance is linear. The covariance of a linear sum with another linear sum is basically a bunch of linear sum. These are just the property of covariance. We will not go too deep into this. And the very important formula is the variance of a linear transformation. So if I have a random variable x and random variable y and I scale them with a constant a, constant b, and a plus c, this will give us the a squared variance x plus b squared variance y times 2ab covariance xy. And if xy are independent, that means they do not affect each other, so the covariance is 0, then we will reduce the formula to this formula. So how do you understand this? There's a square in variance, so we can think of variance as a square operator. Then this is basically quadratic formula, okay? So this is like the variance version of quadratic formula. And for the cross term, by definition, this is covariance. So this is a very important formula.